In this video, I'll be helping you with the ALEKS problem type called using the Pythagorean Theorem to find a sine, cosine, or tangent ratio in a right triangle. In this example, we're given a right triangle. The angle that we are, in this example, finding the cosine for, and we're given two of the measures here, 4 and 7. And in a previous video, we introduced this idea of SOHCAHTOA, where for right triangles, the sine is the opposite over the hypotenuse, cosine is adjacent over the hypotenuse, and tangent is the opposite over adjacent. In this example, we are looking for the cosine, which will be adjacent over hypotenuse. And from the perspective of theta, I can see that the adjacent is 7, but I'll also need the hypotenuse length, and that's where the Pythagorean theorem comes in. So if I called the hypotenuse C, and my legs here are 4 and 7, the Pythagorean theorem tells us that a squared plus b squared equals c squared. Our legs are 4 and 7, so 4 squared plus 7 squared equals c squared. Just solving for c, we would first square our numbers here, 16 and 49. And then we can add, that would give us a 65 equals c squared. To solve this for c, I would need to take the square root of both sides. That will give me a c on the right-hand side, and the square root of 65 on the left-hand side. Technically plus or minus the square root of 65, but these are lengths, so we use the positive. I'll replace my c with the square root of 65. And now, since we're looking for cosine, which is adjacent over hypotenuse, we've said that the adjacent is 7, and we now know the hypotenuse is the square root of 65. This is the exact value, not a decimal approximation, so this would be our solution. I hope you found this video helpful. You can find a complete list of Timely Math Tutor videos organized by course and curriculum at timelymathtutor.com.